This video is all about flow control. So we're going to look at the two main approaches that there are for flow control, and we'll see why you might not want to throw exceptions like you're currently doing in your applications. Then we'll look at some of the most common solutions and a very elegant solution that plays well with domain-driven design principles, which I think you're going to like. Hi everyone, Amichai here. I do have a quick disclaimer if you're new to the channel. So I am a Microsoft employee and these are Microsoft technologies, but I'm not talking on behalf of Microsoft. These are my personal opinions. Okay, now before we start, I just want to let you know that we have dark mode for our fictional application. So because no one asked, I decided to take the time and make our application dark mode friendly. So here you have it. Okay, so what do we have at the moment? And I want us to focus specifically on the register endpoint for now. So we have the register request, which arrives at the authentication controller. And from there, it calls the authentication service in the application layer to actually register the user, which uses the user repository to work against the database. If the user with a given email is already registered, then we just throw an exception. The exception is handled over here in the errors controller, which returns 500 to the user. Now, of course, we don't want to return just 500 to the user always, no matter what exception is thrown. That's why in this video, we'll add flow control to our service, and we'll return the correct error response to the client when an error occurs. By the end of this video, you'll have a deep understanding of the two main approaches for flow control, and you'll be able to take whatever solution you think is better for your application and implement it in your service. Okay, let's get started. Okay, so the first thing I want to do is actually to get rid of all the global error handling solutions we did in the previous video. So we can get rid of this, and of this. Let's include these two. Next, we can get rid of the middleware and the filters. And over here, let's create a new folder. It's called common. And let's move the errors inside the common folder. All we have at the moment is the middleware, which will route the request to the error endpoint, and the error endpoint, which simply returns 500 to the client. Okay, so let's run our service and make sure it behaves like we expect. So we're making the register request. First one passes, second one throws an exception, and here we have our 500. Okay, now let's think what we actually want to do, right? So the problem over here is that we're just throwing an exception. And when we're catching it over here in the errors controller, the only way for us to understand which error this is to parse the exception message. So of course, this solution is not scalable or resilient. So instead, let's go over here. Instead of just throwing an exception, let's throw a distinct exception. So let's close everything over here so it's more organized. Inside the common folder, over here, let's create a new folder. Let's call it errors. And over here, let's create an exception that represents what happened. So let's just say duplicate email exception. Okay, so over here, we'll have something like yes. We can actually get rid of this and simply have it as so. Then we can replace this with duplicate email exception. Now that we have a distinct exception over here, then back in the errors controller, we can have some logic that says, great, this is the exception that was thrown. If the exception is a duplicate email exception, then I want to return 409 and some custom message. So for example, something like status code message. And here we can have exception, which, yes, we can actually make this a bit better. Yes, and over here, let's have it status code 409 conflict. So one thing to notice that this over here is a security risk. So if you have someone just guessing emails, then over here you just told him that he guessed correctly and he can go ahead and start guessing passwords. So it really depends on your application. This might be the appropriate response sometimes, but definitely not always. Okay, so something like this. And then over here we can say status code, and title message. Okay, we should have hot reload. Yes, let's restart the application. Go over here to the request and make the register request again. Okay, first request passed, second request, we threw an exception, and over here we have the details like we expect. Okay, now you might be looking at this and thinking to yourself, let me just close this. So if you are taking the approach of using exceptions for flow control in your application, then currently we have one exception in our system, and it doesn't scale well having over here a giant switch expression which computes the correct response to return to the user. Okay, and that's why another variation of this that many applications use is something like this. So over here, we would create some interface, for example, iService exception. Let me just close this. And over here, you'd have something like this, where you would say, what's the status code? And some message, right? So error message. Then over here we'd implement it and we'd say conflict and the relevant message. And then back in our error controller, then we can say, okay, if it's a service exception, then let's pull the status code and the error message. Okay, let's just cast this to an int and something like this. Let's run the application and make sure that we get the correct response. So we run the application, first request runs successfully, and the second request we can see we get the same response like before. So actually I want to go back to our diagram and see how this solution will scale. So currently what we have, right, is we have our authentication service, which throws an exception, which is caught over here in the errors controller. So as part of this request, we're also generating a token. Now, if you remember, then we're calling the JWT token generator, which is implemented over here in the infrastructure layer, which as part of its implementation calls the datetime provider. So let's imagine that the datetime provider, for some reason, throws an exception. Okay, now I'm giving here this example, but I want you to imagine that it's basically a component calling a component, which throws an exception. What you'll have many times is the same component reused by different components, and the exception that is thrown isn't always mapped to a single error response. So what you'll actually have is you won't be able to catch it over here, handle it, and return a response to the client, but rather, over here in the authentication service, you'll create a try-catch, which will catch the exception that is thrown over here in the datetime provider. Then over here, you'd have some computation, either stored as an inner exception or create some aggregate exception or create a different exception altogether, throw that, and then that's handled over here in the errors controller. Okay, now this may seem fine, but tomorrow morning, the datetime provider might throw a different exception which requires a different handling. And then over here in the authentication service, you need to start creating different catch clauses to catch each one of the different scenarios that might occur. And very quickly, it becomes hard to track the error flow in your application. Right, so I want us to be architects for a minute and imagine how this application will scale. And it's easy to see that when the application grows and we have more and more components and maybe separate teams working each one on a different layer, each one will be throwing exceptions, and sometimes they'll go straight to the errors controller, but sometimes it will go through a different component, which might actually go to a different component, and over there, they'll throw an exception which eventually will be caught over here in the errors controller. And then over here in the errors controller, it's not hard to imagine where you'll start having specific logic to handle all these very special cases that might occur. Now, we haven't talked about domain-driven design yet, but one of the core principles of domain-driven design is having a deep understanding of the behavior in our system. This understanding is a bunch of things that we'll talk about in the future, but one of them is also to know what kind of errors can occur and what happens when they occur. So if you look at this application 2 years from today, where some of the team was replaced with new engineers, and you're looking at the system, and you're trying to understand which errors can happen in our application and how are they handled. So it becomes difficult to understand, because if you think about it, and this is one of the biggest cases against exceptions for flow control, is that exceptions are just complicated go-to expressions, right? So over here we threw an exception. Where are we going to next? Are we going over here? Are we going over here? And you'd have to go through the call stack to actually understand the flow and what happens in the end. Also, when you're monitoring the system, how do you know if the exception that was thrown is an expected exception, like the duplicate email exception, or if it was an actual exception that you didn't expect and you want to investigate? So it becomes hard. You have these two different groups of exceptions, ones that you expect that you'll have and other ones that you don't expect that you'll have. Being able to monitor and understand when exceptional things happen in our system is very important for the stability of the system in the long run. So I do have a small disclaimer before we continue. So this approach is very common, and most of the applications I've seen inside Microsoft and out of Microsoft use this flow control approach, which means that this does work, it can work. So these are just different approaches for the same problem, and you need to choose what's right for you. Okay, so what we're doing today is we're just exploring different options, and I want you to keep an open mind to the different solution and see if this is something that might work for your application. Okay, so let's move on to the second approach, which actually doesn't involve throwing exceptions at all, but rather, when we call the authentication service over here from the authentication controller, we'll either return the authentication result like in the happy flow, or we'll return some object that represents the error that occurred. Then it's the responsibility of the controller to either return an error response or to return the authentication result as expected. Okay, so this will make more sense when we start implementing it. So I'm back to the application and I've reset it to as it was before, where we're just throwing an exception. And I want us to get familiar with a package called OneOf. So to get started, let's add it to the application. So .NET add to the application project, the package OneOf. Okay, and what this allows us to do is to say over here from the register endpoint, I'm going to return either the authentication result or something else. Okay, so in our case, we want to return here some error. So for example, and this is just for now, let's create here a new folder. It's called errors, and let's create here a duplicate email error. This could be whatever we want. So we can have this record struct duplicate email error. And then we can say this returns either this or the duplicate email error. Okay, let's update this over here. So OneOf and duplicate email error. Great, let's include OneOf. Okay, and what this allows us to do is actually to simply return from over here either the duplicate email error, like we're doing over here, or the authentication result over here. Now, if you're wondering how this works, so basically behind the scenes, it has here two objects. It has two implicit converters. So let's look for implicit, where you can see one of them receives the first type and returns the object, and the other one receives the other type and returns the object. Okay, so that's how it's implemented behind the scenes. Great, now back in the authentication controller. So we no longer receive here the auth result. Let's call this the register result. And over here, let's add the explicit types. Okay, then over here, we can say if the register result is T0, basically the authentication result. And then we can say over here that the auth result is register result as T0. So this will return the actual authentication result. Then over here, we can access it like we expect and return the response as we wanted before. If it's not, then over here, we can return a problem and say that the status code is status codes 409 and the title email already exists. And now if you're looking at this and you're thinking to yourself, this is much less readable than the other solution, then you are right. So let's see how we can make this a bit more readable. So first of all, let's extract this to a method. Let's call it map auth result. Then we can use another nice method that we get as part of the OneOf object, which is the match method. So the way this works is basically you can go ahead and do match. Then over here we can pass it two functions, and the correct one will be invoked based on whether the response is an authentication result or the error. So something like this, let's fix it. So let's get rid of all this and fix this. So if we got an authentication result, then we want to map it to the auth response. Then if not, we know it's our error. And over here, we can return the problem with the correct status code that we want and the title email already exists. Great, let's go ahead and run this, make sure that it works. So the first request is sent successfully, and the second one, as we expect, returns 409 and the title that we defined. So if you're looking at this and you're thinking to yourself, how is this supposed to scale better than the other solution that we looked at? Because at the moment, we're expecting only the duplicate email error, but tomorrow morning, like we said, we'll have a component calling another component, etc. And over here, we won't just have two errors, but rather we'd have here 15 different errors that not only the controller needs to know about, but also every component down the road will need to know. So of course, this doesn't scale well. That's why, similar to the iService exception interface we had before, sometimes the following approach is taken. Okay, so let me just close everything so it's more organized. So somewhere in our system, we'd have some interface, something like iError or something like that. And over here, we define some interface which would know how to expect in the controller. So yes, for example, let's change this to iError. Then we can go back to the authentication service interface, change this to iError, both here, both in the implementation and in our controller as well. Then what we can do over here is say error, and then pull the status code from the object, cast it to int, and for the message, same thing, right? Okay, so this solves this issue, but what if we want to support in our system returning a list of errors? Okay, so this doesn't solve it. Now you can create over here a list of errors and receive this, writing something like this for each one of your methods really becomes a mess. Okay, so this brings us to a different package, which is also extremely popular, called FluentResults. Okay, so let's get familiar with that package. Okay, so for now, let's change this back to var, and let's get rid of the OneOf package. So .NET remove from the application layer the package OneOf. Great, we remove the package. Now let's instead add FluentResults. So .NET add to the application layer package FluentResults, and let's update our implementation. So instead of OneOf, we'll return here the result object, which we'll look into in a minute. Okay, add it from the FluentResults and get rid of OneOf. Now let's fix the implementation as well. So result and using FluentResult. Let's just get rid of this using over here. So what is this result object? So similar to the OneOf object, this is also a discriminated union, but instead of us having to define 2 or more results, over here, this will always contain either what we define over here or a list of errors, right? So more than one error. The way this works is that you can either return the object that you said you will return because it has an implicit converter from an authentication result to this result object, or you can return an error. But if you want to return an error, so over here in the duplicate email error, and this is still part of our OneOf implementation, right? So we defined our interface and implemented it over here. So instead of this, let's get rid of the interface, and instead, let's use the interface from the FluentResults library. And instead, let's get rid of this and implement the FluentResult interface. Then over here, you can see that you can hold within one error a list of other errors. So if, for example, this error was caused by another error, then over here you can still contain it inside, sort of like an inner exception. Then over here you have your message. So this is similar to our error message. And over here you have another property where you can put some other information. Okay, for now let's not implement it because we're not going to be using it. And lastly, let's change this to a class. Okay, back over here, even though we're implementing the interface, we still can't return it like we did with the OneOf library. Rather, what we need to do is return result.fail. Here you need to give it the type, and over here you can pass it the error. Okay, now unlike OneOf, then out of the box you can also pass here a list of errors. So something like this should just work out of the box. So this approach, as you can see, is more robust than the OneOf approach. Now I want us to go to the authentication controller and complete this implementation. Okay, so here we can say if the register result is success, then we can simply return OK. And here we want to map our result. So map auth result, register result dot value, right? So this over here is simply the authentication result. Otherwise, we know we have an error in our hand. So let's for now just do something like this. So first error equals register result dot errors, and let's take the first one. And then we can say, okay, if the first error is a duplicate email error, then yes, let's return here a problem with a correct status code, right? Like we did before. And because we didn't implement this property, let's just hard code the message, something like this. Otherwise, let's just return a problem. Okay, and just to note that this over here is more about demonstrating the different properties that we have in our result object and how it could be manipulated and used, and not the actual implementation. Of course, you wouldn't want something like this duplicated in each one of your controllers. So we covered flow control using exceptions and using these two very common libraries. Now, there are actually many libraries that do more or less the same thing, but my personal favorite library, which brings the best of both worlds, is ErrorOr. Now, if you know me and you've heard about this library, then you know I'm not objective because I wrote this library. But really what I was looking for is the intuitiveness of OneOf, the list of errors from FluentResults, but also the option to categorize an error to the various common errors that you have in a system. Okay, so that will make more sense when we implement it. So let's move on to the final approach and what we'll actually be using in the final solution, the package ErrorOr. Okay, so I'm back to what we had in the beginning of the video. So let's get rid over here of everything we aren't going to be using. Let's remove the filters and the middleware. Create a new folder over here, common, and move the errors inside. And over here, let's change the namespace to match the new folder structure. So what we're going to do now is define some errors inside our domain project. These are errors that we know can occur in our system. We want to have them well defined and neatly organized in our domain layer so that as our application grows, we know exactly what errors can occur and what they look like. Okay, so this will make more sense as we go along. So the first thing I want to do is add the ErrorOr package to our domain layer. So .NET add to the domain layer, the package ErrorOr. And over here in our domain layer, let's create a new folder, call it common. Inside here, let's create errors. And in here, let's create errors.user.cs. Okay, and what we're going to have over here, let me just close the terminal, is the following. So public static class errors and public static class user. So over here, let's create that error. So public static error duplicate email. And over here, we can define our error. Now you can see that this error object comes from the ErrorOr library. And you can see that it has here three things. It has a code, which is unique for this error. It has a description, which describes the error. And each one of them has an error type. Now this error type can be one of the following. So failure is the default, and a couple of other error types, which are common error types in any system. Okay, so let's create it. So error dot. And over here, we can use each one of these methods to create the corresponding error object. So in our case, we want conflict. Over here, let's give it some unique code. So for example, user.duplicate email and some description. Let's just wrap it so it's more readable. Okay, next, let's go to our authentication service and update our interface. So this is very similar to the results object. So if we look at how it's implemented, then you can see that all it is, it's either the value that we specified, so the authentication result in our case, or a list of errors, which we already looked at what an error looks like. Great, let's update our implementation as well. So over here, ErrorOr authentication result. And what we can do over here is simply return errors.user.duplicate email. Okay, now back in the authentication controller, let's see how we can use it. So over here, we have our ErrorOr object, and very similar to the OneOf object, then over here, you also have a match method. So return authResult, match, and over here, you can see that you basically have two functions, one that will run if what you have is the actual value, and another one when it holds the list of errors. Okay, so this is match, but there's also match first, which is like the other one, but instead of a function that gets all the errors, it gets only the first error that occurred. So for now, this is just an intermediate implementation. Let's say if we have a result, then we want to return the auth result, again, mapped to an object. So let's extract this to a method. All right, so over here we have the authentication result. Now we can take this over here and put it here. Otherwise, we have here a list of errors, and we want to return, just for now, status code 409, and the message, something like this. Okay, let's just make sure that this works, first of all. So, .NET build, great, let's run it. Yeah, let's watch run it. Okay, first request run successfully. Second request, so return 409 with the hard-coded message. So over here, we can actually make it a bit better. So we can say match first, and then have here the first error. And instead of just hard-coding a title, we can return the description, right? So this will return this message over here. But I actually want us to look at a more holistic approach. So for that, let me just update this to map auth result like we had before and move it to the bottom. So first, let's update the login method to use ErrorOr as well. So the way this looks, ErrorOr, and over here, we'll also have ErrorOr. Okay, now we have here a new kind of error where basically the user gives us invalid credentials. So for this, let's go to the domain project. Let's copy paste this file. Let's change the name here to errors.authentication. Okay, let's update this to be partial class, both here and here. And over here, we'll have all our authentication related errors. So for example, invalid credentials. This could be auth.invalid credentials. And over here, we can have some error like, invalid credentials. Okay, so now let's go ahead and use it. Over here, we can simply return errors.authentication.invalid credentials, both here and here. So I saw this approach first used by my friend Milan. I really, really like this approach. And that's why I ended up creating this library. And one of the reasons why I like this so much, because now we have over here in our domain layer, all the different errors that can occur in our system, and we can later validate very easily when we have an error to see if what we're holding in our hand is the invalid credentials error. In the examples today, we put all the errors inside the domain project, but these could definitely also sit inside the application layer over here like we did before. It really depends on your approach. So for me personally, I like looking at all the errors in the system and put it over here inside the errors. But if this gets too cluttered or you want some separation between errors of use cases and errors of your domain logic, then you can definitely separate it and store some of the errors over here inside the application layer. And this solution also out of the box supports in returning a list of errors. So for example, you could have here a list of errors that you are returning. And what this means is that within one component, you can either return the result, a list of errors, or a single error with the same readability of the OneOf package. One of the nice things about this implementation is that the core logic of our application doesn't need to speak HTTP, but rather it speaks in its internal language. And then over here, what we still have left to do is implement some common component which knows how to take this list of errors and convert it to whatever language that we're speaking. So in our case, we want to return problem details. So how do we take this list of details and return a meaningful problem details response? Okay, so that's what we're going to be doing now. And over here, let's create a new file, which will be the base controller for the other controllers. So let's call it API controller. Okay, so public class API controller. This will inherit from the controller base. Okay, and what we're going to have over here is our problem method, which instead of receiving the problem details, it will receive a list of errors. So public action result problem. This, like we said, received a list of errors. Okay, and for now, let's just return here problem. Okay, so like we said, the other controllers will inherit from it. So this instead of controller base will be API controller. And since we're going to have this attribute on all of them, we can just move it to the API controller. Then over here, instead of match first, let's have this match. Here we have all of our errors, and we can pass it to the problem method that we just created. Okay, let's do the same thing for the login request. So over here, we want to return authResult.match, and then we have here, yes, exactly. I just remembered, I think over here I had this conflict. Yes, and this should be validation. Okay, now back over here. Then, and just one thing about this method. So we'll complete the logic over here after we have model validation in our service. So for now, let's have here something simple. Let's say the first error is the first error. Okay, and then we can say that the status code that we want to return is based on the type. So first error dot type. And here we can say if the type is conflict, then let's return conflict. If the type is validation, let's return bad request. And yes, if it's not found, then not found. And last but not least, internal server error if it's something else. Great. And then over here, we can return the status code. And for the title, the description of the first error. And last thing, we actually want this protected, not public. Let's build a project, see that it works. Right, let's try running it. So the first request, successful. Second one, we successfully converted the error type to the correct HTTP status code. And we pulled the error description to the title. Okay, the last thing I want to do is, let me just close this and this. So looking at the error object, it's a shame to lose the error code that we have over here. This could be very useful when trying to debug the problem that occurred. So if we want to add custom properties to the problem details response, then if you remember from last video, we want to update it over here. Okay, we can see we have here the HTTP context. So let's see how we can use it to share the information within the scope of a single request. So back in the API controller, because we're inside a controller, then we have access to the HTTP context. We can go to the items, and you can see that this is exactly what we want. So let's go over here and add our errors like so. So instead of this custom property, let's make this error codes. And over here, let's put a list of all the error codes that occurred. So errors equals yes. And over here, we want to say if the error codes, say is not null, then let's add them over here. So we can do errors.select e.code. So this should work. Stop the application and run it again. And so first request works, second request fails. And over here, we have all the errors that occurred. Now, one thing I don't like about this is that we have here this hard-coded string that's shared between two different components. So let's go over here and create here a new folder. Let's call it HTTP. And over here, let's have HTTP context item keys. And over here, let's have our constant. So public const string errors equals errors. Great. Now let's replace it. So both here and here. Great. So now we have our general solution set up over here, and we can always have over here our custom logic. So here, for example, we don't really want to return 400 when the user gives us invalid credentials, but we want to return 401. So you can add whatever specific logic you want over here. So auth result is error, and the first error is yes. So status code unauthorized, and the title is the description. Great, just wrap it so we can see it. Okay, so running the program, we register the user. Now let's try to log in with invalid credentials. So this is already the wrong credentials. Let's try, and it works. Great. So that's it for this video. I'm very curious to hear what you think about this approach and whether I got you thinking about switching paradigms and not using exceptions anymore in your application when it's something that is expected. And as always, if you have any insights or you think you have a better idea, then please feel free to educate me. Let me know in the comments and I'll make sure to look into it. In the next video, we're going to start learning about mediator CQRS and how we can split our logic following the different features in our system. So if that sounds intriguing, make sure to subscribe, and I'll see you in the next one.